How's it going, 8th grade? So we're starting off the school year a little bit differently than years past, but that doesn't mean that learning has to be any different. So what I'm gonna do is I'm gonna continue making instructional videos for you that you can watch during your asynchronous time, and better yet, this is gonna be your notes. So it's really important that you take notes on everything that I'm showing in this video, and without further ado, let's get to the topic of the week. This week, we're going to be talking about exponential notation versus standard form. So let's get to it.
So when we start talking about exponential versus expanded form or standard form or anything like that, it's really important to know that that is talking about exponents. But we need to start off with what is an actual exponent? What are its parts? So you're going to have numbers that sort of look like this. So let's call this a 5 and let's call this a 4. So this 5 is called your base. And this 4 is actually your exponent. Okay? And this overall is a power. So it's 5 to the 4th power. Okay? You can use exponents to show repeated multiplication. Again, I know that my handwriting isn't great. Working on it though. So, for example, 3 squared is essentially 3 times 3, which is, of course, equal to 9. But there are two ways to say this problem. So you could say 3 to the 2nd power or 3 squared. Or 3 squared. So 2 to the 3rd power is just 2 times 2 times 2, which 2 times 2 is 4, times 2 again is 8. So again, two ways to say this. You can say 2 to the 3rd power. That does not look like power. Or 2 cubed. Okay, let's go to the next slide. And this is just generally giving you a big description. So it's telling you that 5 to the 6 means 5 times 5 times 5 times 5 times blah, 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 keeps on going, okay? You can see that this is essentially repeated multiplication. This is our notation for that. So x to the n power just means that I'm multiplying x at n number of times. So let's try to go back and forth here. So if it's 4 times 4 7 times, it's simply just 4 to the 7th power. And that's all that I have to write. If it's 3.6 to the 47th power, that just means it's 3.6 being multiplied 47 times. If it's negative 11.63 being multiplied by itself 34 times, then it's just negative 11.63 to the 34th power. That's it. So, the next question is, will these products, the answer to a multiplication problem, be positive or will they be negative, and how do we know? So it's really important for us to think, I know that a negative times a negative, we're going to do this, negative times a negative equals a positive, and a positive times a negative, let's make these thicker, equals a negative. So let's see. If I do negative 1 times negative 1, if I end up doing that 12 times, will I know that I have 6 pairs of negative 1 times negative 1? Sorry, let's change some of that. 6 of these. 6 of these products. So let's just do this 12 times actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Throw some X's in here. So you will want to go back and watch this video a couple times, especially if you have questions. So I have -1 times 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 -1. But again, I know that all of these are just going to be positive ones, so it's really going to end up being 1 times 1 times 1 times 1 times 1 times 1, which in fact equals a positive 1. So I know for -1 to the 13th power, I know that's -1 to the 12th power times -1 one more time. But we already know -1 to the 12th power is positive 1. So this is really like 1 times -1, which is going to equal -1. Now, I know you're probably saying, Mr. Gerber, this seems like it's a lot going on. I should probably try to figure out an easier way to go about this. I want to point something out for us here. When I look at my exponent here, it's odd. When I look at this exponent, it's even. When I had an even exponent, I had a positive answer. When I had an odd exponent and my base was negative, that means that I got a negative answer. So let's write that on the page here. So negative base, let's just make this into a little graph. Negative base, if I have even exponent, I'm going to have a positive answer. If I have an odd exponent, I'm going to have a negative answer. Great. One last slide. So, fill in the blanks indicating whether or not the number is positive or negative. Right here it's saying if n is a positive even number. So I know that I have a negative base and an even power or an even exponent. That means that my answer is going to be positive. Now it's saying if n is a positive odd number, I have a negative base, an odd exponent, which means that my overall answer is going to be negative.